Welcome back to my YouTube channel. In the course of this video lesson, I'll be solving different practice questions that cut across different topics in chemistry. Now let's get into the first practice question, which says, which of the following is the electronic configuration of sodium? Now, this question is extremely very easy. When we see a question in chemistry, we must try first to determine the topic to which the question is from. And from the look of things, this particular question is from the topic in chemistry called atomic structure. So this must be noted. Okay, the topic to which this question is from is called atomic structure. So, moving further, you can see from the question they are asking us to determine what we call electronic configuration of sodium. So, it is not for me to just teach you how to determine the electronic configuration for sodium, but it is important for me to teach you how to write electronic configuration of all elements, because in your Jamb exam, they might change this element from sodium to another element. So it is important for you to know how to determine electronic configuration for every element in the periodic table. And to do that is extremely very easy. You just have to know about a principle in chemistry called the Aufbau principle. So this must be noted. I will explain how this principle works and teach you every single thing you have to know on this aspect. So you must first know a principle in chemistry called the Aufbau principle. This must be noted. Now moving further, the Aufbau principle is also called the build-up principle. And there is a man that actually brought about this principle, and what he actually said is that he said that electrons should occupy orbitals first before it progress. You can see I have mentioned orbitals. We have to know the orbitals we have in an atom or in chemistry in general. We have different orbitals which include the s orbital, which include the p orbital, which include the d orbital, and also the f orbitals. We have other orbitals like the g and h orbital, but I'm not talking about that because those orbitals are actually using more complex elements. All of these elements are not complex, all right, but it is important for you to know how to do it, which I'm about explaining now. So listen carefully. So let's take the principle again. This principle called Aufbau's principle states that electrons should occupy orbitals, all of these are orbitals, of lower energy before those of higher energy. Now, let me summarize what this man was actually trying to say. So watch closely. He now brought about a chart to actually write out electronic configuration, which I'm about writing on the board, and I will teach you how it's done. So listen carefully. So this is what the Aufbau principle was now summarized to be. All right. So here first we have the 1s, we have the 2s, we have the 3s, we have the 4s, we have the 5s, and also we have the 6s. So if you observe, I've written for all the s orbital, which was the first orbital mentioned. So let's go over to the p orbital. For me to write the p orbital, I will skip 1s and start from here. Are you there? So it's going to be 2p, 3p, 4p, 5p, and 6p. Are you there? So going over to the d orbital, what should I do next? Simple. I will skip these two and come here. So it's going to be 3d, 4d, 5d, and 6d. So moving further to the f orbital here, you can see for me to write the f orbital, I'm going to skip this and come here. So it's going to be 4f, 5f, and 6f. That was what the man was trying to do. But I'm going to teach you exactly how to just, write out electronic configuration. I cannot just, come here and tell you the answer, that the answer is option A, option B, option C, or option D, and I don't explain why the answer is the answer. So it is important for you to know why the answer is the answer to a particular question. So the next thing we do is to now start drawing arrow, like lines down this orbital. So this is what I mean. For the s orbital, we'll draw a line coming down like this. For the 2s, we'll draw a line as well. You can see 2p and 3s in a particular line, so I'll draw a line down as well. I believe you are following me. For the 3p, watch closely. The 3p, 4s, they're in a line. I'll draw a line crossing them together. If you observe 3d, 4p, 5s, they're in a line as well. I'll do the same. Are you there? Same applies to 4d, 5p, and 6x. They're in a line as well. I will draw that line as well. So if you observe, you can see all the lines I've drawn. So how do we now write the electronic configuration of sodium or any element at all? Very simple. We just have to note something. And what do we have to note? There is a very, very important keyword to write out electronic configuration of any element. And that keyword is simply called electron. I know, see, from the word electronic, we can see electron. This will tell us something. Now, in an atom, generally in chemistry, in all atoms, remember that an atom is made up of 3 important subatomic particles, which I call pen. P, E, N. What is P? Proton. What is E? Electron. And what is N? Neutron. Are you there? So moving further, let's say for instance, we were given an atom which is unknown, atom X. And this is how all atoms are written. X, here will be A and here will be Z. And they are asking me to determine the numbers of protons, electrons, and neutrons in this atom. How will I do that? I already have a full video lesson on how to actually determine the numbers of protons, electrons, and neutrons in an atom. But I have to summarize this because we need it here. So to do that, to get my pen of an atom, it is very simple. Now, proton number is basically the number that is down. Are you there? Before we do that, I have to identify all of these things. A here has a name. We call A atomic mass. Are you there? If I have to call A atomic mass, I'll call it another name. And that name is simply mass number. Are you there? That is for A. Watch closely. For Z, what is the other name for Z you are looking at here? Z is simply called atomic number. And if I don't have to call it atomic number, I can simply call it proton number. So this tells us that my proton number is always what is down. My proton number is always Z. So if we were to determine the proton number seen in an atom, it is going to be Z. Are you there? Whereby for electron number, to determine that is also very important. Now, atoms can be of 2 types. We have atoms that are neutral and atoms that are charged. For this, it is neutral. There is no sign. If there were to be a sign up here, there will be either plus or minus. But now, this does not have any sign. I did not tell you that this has any charge. So, automatically, this atom is neutral. But we have other atoms that are charged. For atoms that are neutral, your proton number and electron number are the same. So, since my proton number is Z, my proton number is what is down, automatically my electron number should be my proton number as well. Because I just explained to you that for a neutral atom like this, proton number is equal to electron number. Are you there? But for those atoms with charges, either plus or minus charges, proton number is not equal to electron number. Are you there? And lastly, how do we get our neutron number? Very easy. It is solved by saying what is up minus what is down. So it is A minus Z. Are you following me? It is extremely very easy. So I believe you are following what I'm doing. It's actually very important. But for those that are charged, like in this case, Z, sorry, ox-Az, and here is either plus or minus. Then to get your proton, electron, and neutron, the things are just, they are almost the same, but just few difference. And the difference here is seen in the electron number determination. Your proton number is still what is down and it's still Z. Your neutron number is still solved by saying A minus Z, as what I just explained here. Whereby for your electron number, it is not same as your proton, because now this atom has a charge. So how do you get your electron number? Is solved by saying proton number, which is P minus charge. Are you there? It is very, very easy. It is not difficult. Watch closely, because at the end of solving this question, I'm going to give you one practice question so you solve and provide the answer in the comment section. So moving further, they gave us a very key information in this question, and the information is the atomic number of sodium. So they gave me the Z for sodium. Are you there? It is very, very easy. Moving further, you can see that they gave me a very key information in this question, and it is the atomic number of the element sodium. Remember, sodium is symbolized as Na. You can see that they gave me the atomic number to be 11. Now, where did I tell you atomic number is located? You can see that I told you atomic number is located down, that's Z. So my atomic number is 11. Are you there? But me, I actually know how sodium should be written exactly, because they did not really give us all the information for sodium, but they just gave us what we need to solve this question. But it's important for me to just tell you that sodium mass number, or atomic mass, the one that are up, is 23. So it's important for you to know that as well. So moving further, what are they asking us to do? They are asking us to determine the electronic configuration of sodium. So on that, what exactly do we use to write electronic configuration? That's what I'm trying to explain for you. What we use exactly to write electronic configuration is simply electron number. Are you there? Because you can see from the word electronic, there is electron in it. So for instance, we are to determine the pain of this atom, and did not tell us that the sodium was charged. They told us that it is just sodium itself, neutral sodium. So let us determine the proton, electron, and neutron number for neutral sodium. If it was charged, we'll go over there to use that I just explained. Okay, so proton number is 11. I believe I've explained that for you. Proton number is what is down. Electron number and proton number are the same for a neutral atom. I've explained that already. So electron number should be 11 as well, because electron, proton, they are the same for neutral atoms. Whereby for neutron number, it is solved by saying what is up minus what is down. What is up is 23, which is A, minus Z, which is 11. And when we hit our calculator, we are going to get 12. I believe you are following me. But what exactly do we use to write electronic configuration? It is simply electron number. Are you there? It is not proton number, because in some other cases, they will give you a charged atom and they will tell you to write electronic configuration. So moving further, we use specifically the electron number to write electronic configuration. I know why I'm telling you this, because it is very, very important. Okay, at the end of solving this question, I'm going to show you something that is very, very key in this aspect as well. So what number are we going to use to write the electronic configuration? It is 11. So we'll come over here and start. Meanwhile, you must know that all of these orbitals have the specific number of electrons they can occupy. Then you should know that for the s orbital, it occupies a maximum number of electrons to be 2. The maximum number of electrons that should occupy the p orbital is 6. The maximum number of electrons that should occupy the d orbital is 10. And the maximum number that should occupy the f orbital is 14. So if you watch closely, you can see that the difference is actually 4. Are you there? So let's write the electronic configuration for sodium together. So it's going to be, we'll start with this. As the arrow is coming there, that's how we write it. So we'll start with the 1s orbital. And remember I said that s orbital occupies the maximum number of 2 electrons. So it's going to be 1s2. Remember, we are working towards getting 11 electrons. Are you there? Not 11 protons. There are two different things. Are you there? So 1s2, what's the next? 2s, because after here is here. Are you there? We are going down like this. Just watch. 1s to 1, 1s2, 2s, that's the next. So here should be 2s And since it's still under the s orbital, so we'll go over here and know the electron that's issued, right? So it's going to be 2s2. The next should be, now if you observe, we are coming down, so you must come start with the 2p first before you go over to 3s. So it's going to be 2p6. Are you there? So what's the next? 3s, because p occupies the maximum number of 6 electrons. We are working towards writing 11. So the next is 3s. All right, I'm going to write 3s. And what's the maximum number of electrons can occupy? 2 electrons. So let's write that first and count. So 3s2. Let's count if it's actually 11 or more than 11 or not up to 11. So 2 plus 2, what's that? That's 4. 4 plus 6, what's that? That's 10. And 10 plus 2, what's that? That's 12. So because it has exceeded the number they gave us for, we have to reduce this number, and it's going to be 3s1. Are you there? So I believe if it is 3s1, then it is actually the electronic configuration. It is actually the EC. EC means electronic configuration for which element? Sodium. Are you there? So specifically what sodium? Neutral sodium. Sodium without any charge. Are you there? So moving further, here is your own practice question. So you can see from the information we got, it corresponded to what option? Option B. Because option B is 1s2, we have the 1s2, 2s2, 2s2, 2p6, 2p6, and 3s1. So you can see option B is the answer to this question. It can be option C, option A, or option D. Are you there? So get ready for your own practice question. Your own practice question is to write for the electronic configuration for the following atoms. So you write for this one, which is calcium, mass number 40, atomic number 20. You are writing for calcium again, but here is charged, and here is still 40, and here is still 20. It is simple. Both of them electronic configuration, they are different. They are not the same. That is why I told you to write electronic configuration, use what? Electron number. So first, the rule is to determine your numbers of protons, electrons, or neutrons. Just get number of electrons straight. Okay, you have to follow the steps I give to you. It is not difficult. All right. So since this guy is charged, B is charged, you solve for the electron number by saying your proton number minus charge. So you come here, here's your proton number automatically. I've explained that already. Proton number minus your charge. So 20 I'm not going to say much. 20 minus your charge. The charge is plus 2. So 20 minus plus 2. Minus times plus, that is minus. Mathematically, minus will cancel plus. Are you there? So 20 minus 2 in general is going to be 18. So you are working for 18 electrons in the B. But here, since it's neutral, proton and electrons are the same. So you are working for 20. Are you there? So the C, which is the last one, you have to write the electronic configuration for this element, which is aluminium, Al3 plus. Here is 27 and here is 13. Yes. So these are your own practice questions. So you solve and provide the answer in the comment section. At the end of getting the correct number of electrons, coming here won't be difficult for you. I've explained all what you need. So let us get into the next practice question.
To have more understanding about chemistry calculations and solving all of these type of questions, I already have them on the chemistry masterpiece, okay, which is calculations and keynotes in chemistry. So if you are preparing to write the Jamb exam, this book is very, very important for you. Now, for more information getting the chemistry masterpiece, do well to direct message me via my WhatsApp number. It will be on the screen.
The next question says, the mass number of an atom is, so they are actually telling us what is the mass number of an atom. Before we look at the options, let's determine the mass number together. Let's take this written down. So watch again. Here is X, here is A, and here is Z. This is an unknown atom. Let's label this atom. A here is called the mass number. All right, and I believe you know that mass number is also called atomic mass as written here, and this one that is Z is called the atomic number. Are you there? And if I don't have to call it atomic number, I simply call it proton number. Please note that it is very, very important. So let us assume we want to determine the pair of an atom, which is simply proton, electron, and neutrons. How do we do that? Simple. We already said that for a neutral atom like this, if you can say I'm emphasizing on neutral and also emphasizing on charge, This is neutral. There is no plus or minus. If there were to be plus or minus up here, it's going to be charged. So how do we get our proton, electron, and neutron? Simple. Proton is always what is down and proton is Z. Since it is neutral, proton, electrons are the same. We've talked about that. So electron is equal to proton number. And you already know that proton number is also equal to the Z we said initially. And how do we get our neutron number? It is solved by saying what is up minus what is down, which is A minus Z. Are you there? So moving further, what do we do next? It is very, very easy. So since we've established all of this, and the question, let's get back to the question. It says the mass number of an atom is, they are not, what's the mass number of an atom? It has its own definition. That's what they mean. The mass number of an atom is, so we already know this A is the mass number, all right? So let's try and bring out what this mass number actually is by going to the formula we've actually brought out and trying to make the mass number itself subject. You know, if we can have a mathematical expression, we can actually know what it is exactly. So now, I can only see A down in this neutron number determination. Then I'll write the formula, I'll note the formula, which is this. Neutron number is equal to A minus Z. So write it again. Neutron number is equal to A minus Z. So let's make A subject. Making A subject is going to be this Z will come here. This Z will cross the equality sign. So when it crosses, it's going to be plus Z. When it crosses the equality sign, it's going to be plus Z. So it's going to be neutron plus Z that just crossed. Are you there? So now we can actually, without even looking at the option, we can actually know what mass number is. So mass number is going to be the summation or the sum of neutron number and this plus means and you are joining something to yourself. What's Z? What's Z? Z is called what? Atomic number or proton number. So we can simply say that mass number is the sum of neutron number and what's this Z? You can either call it proton number or we can as well call it what now? Atomic number. I believe you are following me. So it's simply the summation or the sum of neutron number and proton number. Or we can as well say neutron number and atomic number. So let's get back to our question and know what it is exactly. So the mass number of an atom is option A, the number of electrons. Did we even talk about that? So that is out already. Option B, the number of proton. Is it just the number of proton? No. It should be the number of proton and number of neutron or atomic number and neutron number. That's the summation of atomic number and the neutron number as well, because atomic number and proton number, they are the same. So option B is number of neutrons in an atom. Did we say that the mass number is just the number of neutrons? No, we did not say that. So option B is now the sum. Wow, the sum of the number of proton and neutron. We said that already. The sum of the number of what now? Proton and neutron. That should be the mass number of an atom. So the answer to this question becomes option D. Okay, so option D is the answer to this question. So let's get into the next practice question, which is question number 3, and it says, when sodium nitrate dissolves in water, delta H, this we are seeing as delta H. You know, anything that looks like this in science, it means change. Are you there? So it is simply change in H. And what is that H? H is called heat content of a reaction, or we can call it one term called enthalpy. Enthalpy is simply the heat content of a reaction. So delta H is just the change in the heat content of a reaction. Are you there? So what does this tell us? Delta H tells us two major things. It tells us if in a reaction heat is absorbed or heat is given off. And in those reactions that heat are absorbed, we say those reactions are endothermic. But in those reactions in which heat are given off, we say those reactions are exothermic. Are you there? We also use signs to actually determine a reaction that is endothermic or exothermic. This is what I mean. So let's say delta H is positive. We say the reaction is endothermic. Are you there? But let's say that reaction is negative. We say that reaction is exothermic. Are you there? For you to be endothermic, you absorb heat. For you to be exothermic, you give out heat. Are you there? So let's get back to the question. Wow, we've analyzed it already. So it says when sodium nitrate dissolves in water, delta H is positive. That's what they gave to us. So that said that this means that, what does this mean? I've explained it already for you. Option A, the reaction is catalyzed. That is wrong. That's not why delta H is positive. Though the reaction can be catalyzed, but that is not the reason why delta H is positive. Because they're asking us, okay, why is now this delta H positive? It's simple. Just look for the part of the option that has endothermic reaction in it. And from the look of things, option C says the reaction is exothermic. Option B says the reaction is complete. Option C says the reaction is exothermic. And option D says none. Actually, this place that is exothermic should be endothermic. All right, take note of that, because the delta H in the question was actually positive. If you are positive delta H, you are endothermic. If you are negative delta H, you are what now? Exothermic. Take note of that. So the answer to this question becomes option C. Are you there? So let's get into the next practice question, which says the general formula for alkyl halide is. So both of them are two different things. You have to know what alkyl is and what halide is. Now, alkyl most times is symbolized as arrow, whereby halide is symbolized as X. This arrow, which is called the alkyl group, also have its own formula, and the formula is simply CnH2n plus 1. Are you there? That is the formula for arrow. If you want to call it arrow, we can call it this, or we can call it the alkyl group. So adding it with the halide, which is X, anything that's halide is most likely going to be an halogen. Remember, halogens are group 7 elements of the periodic table. So it's going to be, in general, removing arrow and putting this is going to be what now? CnH2n plus 1x. So this is the general formula for alkyl halide. If there is arrow X, you can use the other. I believe you are following. It is very easy. So let's get into the next practice question. Question number 5 says, the acid used to remove rust from metals is hydrochloric acid, HCl. And the process whereby an acid is used to remove rust from metal is called pickling. This must be noted. So let's get into the next practice question, which says oxides in which the oxidation number of oxygen is -1 is. This set of oxides are called peroxides. This must be noted. They are called peroxides. You know, we have different types of oxides. We have peroxides, we have acidic oxides, we have basic oxides, we have neutral oxides. Are you there? So, what is this oxide all about? It's simply a type of compound that is made up of oxygen and another element. You can see from the word oxide. That means there is oxygen for sure and another element. So if the element is a metal, that oxide should be a basic oxide. Are you there? If the element should be a non-metal, Nm, that oxide should be an acidic oxide. Are you there? We have other cases whereby metals are amphoteric oxides as well. But this is just like a general understanding. We have some few exceptions of metals that are amphoteric. And for you to be amphoteric, for you to be an amphoteric oxide, means that you have either the property of an acid or a base. I said either the property of an acid or base. But we have set of oxides that neither behaves like an acid or a base. They don't stand anywhere, so we call those set of oxides neutral oxide. And that is the next question, and it says oxides that are neither acidic or basic, we call them neutral oxide. And a good example is water, which is H2O. Remember I told you, for it to be an oxide, there will be oxygen in you and another element, and water is one of them. Water is a neutral oxide. Are you there? So let us progress. Question 8 says, the allotrope of carbon that is regarded to be one of the softest mineral is what? You know that carbon has two groups of allotropes. We have what we call the crystalline allotropes and the amorphous allotropes. On the crystalline allotropes of carbon, we have two majorly, which are diamond and graphite. On the amorphous group, we have different examples like coal, like the likes of charcoal, like the likes of lamp black, like the likes of soot. So now they're not asking me. So just note this. Graphite is one of the allotrope of carbon that is regarded to be one of the softest mineral in nature. So the answer to this question becomes graphite. I believe you are following. It is very easy. So moving further to the next question, which says the purest form of amorphous carbon is called, they even specify, they said amorphous allotrope of carbon. What is the purest form of the amorphous allotrope of carbon? First of all, what are the amorphous allotropes of carbon? Just watch. Here are the amorphous allotropes of carbon. Here are the examples. We have the likes of coal, we have the likes of charcoal, we have the likes of soot, all right? We have the likes of lamp black. So actually here, the purest form of the, all of these are the amorphous. So the purest of them is charcoal, but specifically because we have three types of charcoal. We have sugar charcoal, charcoal gotten from burning sugar. We have animal charcoal, charcoal gotten from burning the bones of animals, and wood charcoal, charcoal gotten from burning wood. So actually, you must know here that the purest form of the amorphous allotrope of carbon is simply called sugar charcoal. So the answer to this question becomes sugar charcoal. I believe you are following me. It is very, very easy. Whereby moving further, they now said question number 10 says the coal mainly found in Nigeria is what? We have different examples of coal. We have coals like bitumen, we have coals like anthracite, we have coals like peat, we have coals like lignite. Lignite is also called brown coal, and this is the coal that is mainly found in Nigeria. It is called lignite. If we don't call it lignite, we call it brown coal. This must be noted. Moving over to the next question, which says the purest and the hardest form of coal is called anthracite. Please don't get confused from the purest form of amorphous allotrope of carbon. Now, they are being generalistic. They just said, what is the purest form of amorphous allotrope of carbon? It is called charcoal, but specifically it should be called sugar charcoal. But here they are not asking us the purest and the hardest form of coal. Remember, coal is under the amorphous allotrope of carbon. So we are in the coal group now. So which is the purest and the hardest? It is called anthracite. And anthracite, I just mentioned earlier, it is an example of a coal. So moving further to the next question, which says burning of coal in the absence of air. What's it called? Simple. It is simply called destructive distillation. Destructive distillation of coal. When you burn coal in the absence of air, it's simply called destructive distillation of what? Coal. And we have different products we get. When we do this, we have the likes of coke, we have the likes of coal gas, we have the likes of coal tar, and even we have the likes of ammoniacal liquor. But when we burn wood in the absence of air, it's still the same process just mentioned. It is called destructive distillation of wood. And here we have different products like likes of wood tar, wood gas, pyrolignos acid. Are you there? These are the products we get when we burn wood in the absence of air. So moving further to the next question, which is question number 14, it says list two gases that can deplete the ozone layer. Remember, the ozone layer is the layer that covers, all lives from ultraviolet rays from the sun. And one of the major components of ozone layer is trioxygen, which is O3. Are you there? Whenever you hear ozone, your mind should go over to O3. So there are gases that actually can deplete it, that can actually pull holes in the ozone layer. Those gases are the chlorofluorocarbons. We call them CFCs, the chlorofluorocarbons. And as well as even this gas, which is CO, carbon monoxide can also deplete the ozone layer. Are you there? So all of these things are very, very vital. You must take note of them. So moving over to the next question, which is question number 15, which says, when a metal can give off musical notes when hit by an object, it is called malleability. Is that true? Very wrong. The statement is wrong. The statement is false, because whenever we take a metal and hit it by an object, it gives off sound. You simply say the metal is sonorous, not malleability. Malleability has to do with you taking a metal and beating that metal into a flat sheet, not giving off musical notes. Are you there? So let's progress to the next question, which is question number 16, and it says, metals have low densities. Is that true? That is false. Metals have high densities. Are you there? Not low densities. So let's get into the next question, which is question number 17, and it says, what is the flame to test for sodium? Very simple. It is called the golden yellow flame. So when we see this flame, most likely it's going to be sodium. Are you there? This question is extremely very easy. So let's get into the next practice question. So let's get into the next practice question, and it says, in the medical field, that's the medical profession in general, be it in the field of nursing, medicine, pharmacy, as the case may be, okay, then I said radioactivity is used in the following aspects. You know, radioactivity is applied in medicine, is applied in nursing, applied in pharmacy as well. So outline which substance is used in the following processes. So you can see the first one is treatment of cancer. There is a very, very important isotope in chemistry that is used in the treatment of cancer, and that is called cobalt 60. Take note, it is very, very important. That's what they ask. They will bring out the substance. They will tell you the process, and they want you to tell them the substance that is used in that process, and it is cobalt 60 in the treatment of cancer generally. But moving further, treatment of cancer of the thyroid gland. You know, the thyroid gland is located at the neck region, all right? So the treatment of the thyroid gland is basically done by another isotope in chemistry called iodine 131. This must be noted. Are you there? So moving over to the next question, which says, leukemia, was it treated by? This is treated by also a very important isotope, which is called phosphorus 32. All these things are very, very important. I'm moving over to the next question, which says, to detect fractures in bones, what is the simplest diagnostic tool to actually do this? It is simply called the X-ray. Are you there? The X-ray is basically the diagnostic tool, one of the simplest diagnostic tool to actually, detect fracture in bones.
So have more understanding about chemistry calculations and solving all of these type of questions. I already have them on the chemistry masterpiece, okay, which is calculations and keynotes in chemistry. So if you are preparing to write the Jamb exam, this book is very, very important for you. Now, for more information getting the chemistry masterpiece, do well to direct message me via my WhatsApp number. It will be on the screen.
Okay, guys, moving further, let's get into the next practice question, which says, question number 22, it says, the point at which the three major states of matter coexist together is simply called triple point. Please take note of what I just said. It is extremely very important. The point at which the three major states of matter, which includes solid, liquid, and gas, meet together, coexist together, is called triple point. We have other examples of points like boiling point, melting point. You understand? But triple point has to do with the three states of matter coexisting together. So let's get into the next practice question, which is question number 23, and it says, the type of motion seen in gas particle is simple. It's simply called random motion. Are you there? Random motion is seen in gas particles. But for solid particles, they undergo a type of motion called vibrational motion. They vibrate at a fixed point. For liquid, they undergo a type of motion called translational motion. Are you there? So let's get into the next practice question. And it says, when a substance like camphor changes directly from solid to gaseous state, the process is called Camphor, it was solid before you know, we no longer saw the camphor. What just happened? It is a process called sublimation. So this will come to your mind that sublimation is the process whereby a solid particle can change directly into gaseous form. Camphor is one of the examples of substances that can undergo that. We have other substances like naphthalene. Naphthalene can also undergo sublimation. Dry ice can also undergo sublimation. Benzoic acid can also undergo sublimation. Are you there? So let's get into the next practice question, which is, air is a mixture of gases. Is that statement true? Yes, air is a mixture of gases. There are different components of air. Air has different components which range from, oxygen, there is nitrogen, there is carbon dioxide, there is noble gases, there is water vapor, there is dust. Are you there? Nitrogen forms the greatest percentage of, percentage in air. It makes up 78%. Oxygen, 21%. Carbon dioxide, CO2 is 0.03%, and even noble gases is less than 1%. So let's get into the next question, which says, the plum pudding theory of an atom is a theory which in subsequent video I'm going to explain what it is. But you must know that this theory was brought about by a man called J.J. Thomson. So J.J. Thomson brought about this theory, which is called the plum pudding model of an atom. So let's get into the next practice question, which says, the discovery of symbols to classify elements was done by who? Berzelius actually did that. Berzelius brought about symbols to classify elements. The sodium you know to be Na was brought about Berzelius. The hydrogen you know to be H brought about by Berzelius. Are you there? So all these must be noted. Berzelius. So all these must be noted. So let's get into the next question, which says, discovery of atomic number was by who? Very simple. Henry Moseley discovered atomic number. Henry Moseley. So let's get into the next practice question, which is, acid turned blue litmus red. Wow, is that statement true? Yes, it is true. Acid always turn blue litmus paper red, but bases does the opposite. They turn red litmus paper blue. Are you there? So all this must be noted. So let's get into the next practice question, which says, acid solutions have their pH to be less than 7. Is this statement true? It is very true. Now listen, all this will be explained in the pH scale. We have a scale in chemistry called the pH scale, and this scale ranges from 0 to 14. This is called the pH scale. At the middle, we have 7. Specifically, from pH 0 to pH 6.9, when we see any value between these, numbers, we say that solution is acidic. But when we see another solution that ranges from 7.1 down till 14, we say that solution is basic, or we can say it is alkalinic. Are you there? Because with this, we'll be able to answer all these questions below. All right, but there's something I have to tell you. As you go towards 0, you can see an arrow going towards 0. Your acidity increases. Take note. As you go towards 0, your acidity what? Increases. As you go towards 14, there's another arrow going towards 14. Your alkalinity increases as well, which has to do with the basic property of that compound. Are you there? So as you go towards 0, acidity increases. As you go towards 14, alkalinity also increases. So with this information, let's solve all of these practice questions below. So here is the question. It says, between these solutions below, which of them is most acidic and basic? So let's walk towards 31 first. Let's say 31, you'll be able to do the rest. It's simple, just watch closely. Because all of these things I just wrote here, they can bring it to your exam, but they will not start putting all of these things into statements. Then, if you have a very good understanding on the principle of pH, you'll be able to tackle those questions without stress. So make sure you comment down the remaining question I'll be leaving for you to answer. And it says, solution A has its pH to be 2, and solution B has its pH to be 5. The question, because both of them are acidic solutions, but what I'm trying to tell you now is which of them is more acidic? That's what the question is saying. Most acidic and basic. Which of them now, between question 31, is more acidic? It is solution A. Why is it solution A? Because its pH is 2. Its pH is closer to 0. I told you as you go towards 0, acidity is going to increase. As you go towards 14, your alkalinic property or basic property of that compound should increase as well. I believe you understand what I just explained. So moving further, with all what I've said based on the pH scale, you use it to analyze from question 32 to question 35, because it's on determining which of the solution is more acidic or more basic or alkalinic. You know, if the number is greater than 7, then it tells you that those solutions are basic. So to determine the one that is more basic, you try to look for the one that is closer to 14. Because I said as you go towards 14, your basic property should increase. Are you there? It is very simple. So moving further to the next question, which says, that's question number 36, and it says, acids have bitter taste. Is that true? No. This statement is false. Acids have sour taste. Are you there? Those compounds with bitter taste, they are called bases. Are you there? So this must be noted. So moving further to the next question, which says acids are soapy to touch. Very wrong. Okay, it is bases that are soapy to touch. Now moving over to the next question, and it says what is used to dry all gases? Very simple. It is called silica gel. Silica gel is used to dry all gases. All right, so moving over to the last question, which says what dries ammonia in particular? What dries ammonia in particular is called quicklime. All right, quicklime dries ammonia in particular. Please take note of these things. These are some possible questions that can just come out in your exam. All right, so quicklime dries ammonia as a gas in particular. So we've come to the end of this video lesson. If you find my video lesson helpful, make sure you click the subscribe button to my channel and also share my video lessons with your friends. Thanks for watching.